Welcome back. So in the last example we learned that if a voltage waveform is given, then how we can find the current, energy and beyond. Okay, now let's have a look at another example for the capacitors, where basically the capacitor current is given and we need to find out the voltage, okay, and the power. So this is the current waveform which is given, and we need to find out the voltage and power for a capacitor with a value 4 microfarad. Okay, so first of all, let's write down the formula for the voltage through the capacitor, okay, across the capacitor. So voltage across the capacitor is initial voltage plus 1 over C integral of the current through the capacitor, right? So we need to find out basically what is the expression for the current. Because the waveforms, we will use the same approach like we did earlier. We will divide the waveform into two parts because it's a different, okay, trends in the two regions like this and this. So we can divide from 0 to 2 milli and then from 2 to 4. So let's find out what is the expression for the current for 2 to milli. Okay, so to find the expression, this is a straight linear line. So the current will be basically what? Slope multiply with time. So to get the slope, we need to define the points. So this is our basically first point, that is basically 0 and 0. Second point, what is the time? 2 milli. And what is the current here? So if this is 15, so this is going a bit above, so approximately 16. 16, remember the units, it is microampere, 16 micro. This is very important that we use the correct units. All right, let's find out the slope. So what is the slope here? Y2. What is Y2? Like this is X1, this is Y1. So then that will be X2 and Y2. So Y2 16 micro minus Y1. What is Y1? 0 divided by X2. What is X2? 2 milli minus 0. Okay, so 16 divided by 2, that will be basically 8. So this 10 power minus 3 will go on top, so it will become plus 3 multiplied with 10 power minus 6, it will become 8 power minus 3. So it means our slope is this one. So our current function formula will be basically slope multiplied with t for 0 to 2 millisecond. Now using this, let's calculate the voltage. So the voltage for this case will be initial voltage. So we are talking from 0 to 2, so initial point is basically 0. So what is the voltage at 0? Plus 1 over C. What is the value of C? 4 micro. Integral from T naught to T. So what is the T naught? Our first point, right? So which is basically 0. So from 0 till T. Current. What is the current? 8 times 10 power minus 3 T. And we need to integrate this. So one very important thing here is make sure, okay, that this point is clear, that we are going to integrate from T naught, the previous point, till T. So for example, we are integrating from 0 to 2, so we will not integrate from 0 to 2 actually. So T will be the variable so that we can get basically the expression, okay, the formula for that. All right, moving on. So now we need the voltage value at 0. Okay, that was the initial condition. Okay, so this is given in the question. Okay, most of the time initial conditions will be given, like does capacitors have any stored energy, any voltage drop across it before placing to the new circuit. So for this case, this is 0. So let's plug in the number here. So voltage is 0, and plus this 8 times 10 power minus 3 is a constant, so we can take it outside, divided by 4 times 10 power minus 6. And now we are left with what? T. So what is the integration of T? That will be T square divided by 2. Put up the limits, okay, 0 to T. All right, let's simplify this one. So 8, so this 2 will come outside, okay, so this will become 4 times 2, 8. So 8 and 8 will be cancelled. So we have 10 power minus 3. So basically this will be cancelled. So 10 power minus 3, this 10 power minus 6 will come on top. So it will become basically 10 power 3. So let's put up the upper and lower limits to simplify this integration. So what is the upper limit? T. So if I put upper limit, that will be T square minus lower limit. What is the lower limit? 0. So 0 square. So 0 square is 0. So basically the answer will become 10 3 power 3 times T square. Okay, so that is basically the voltage, okay, for this case for the time interval from 0 to 2 millisecond. Okay, so we can write this as 0 to 2 millisecond. We can also write this as like the time interval is basically greater than 0 and less than 2 milliseconds. So these both represents the same thing. So second thing is we need to calculate what will be the voltage again from 2 to 4 millisecond. So from 2 to 4 millisecond, so again we need to find out what is the current for this case. Now if you look at this waveform, for this case the current is basically kind of a constant. Why constant? Because from 2 to 4 we have the straight line. So what is the value of this straight line? So this value will be could be around -8. So it's a constant, so we can just write at -8 micro. Okay, that's it. Okay, because the value is constant here. All right. Now let's calculate the voltage. Okay, for this case. So voltage will be what basically? Okay, what is the formula for the voltage? We are talking about from now 2 to 4. Okay, initial voltage. Okay, so initial voltage at 2 plus integration from 2 till t for the I. Okay, 1 over c here. Okay, what is the c? 4 micro, right? I, what is I here? -8 times 10 power -6. Okay, and we are going to do the integration of this thing. Okay, all right. So now initial condition is we need to know what is the voltage at 2. Okay, what is the voltage at 2? Okay, here. So how we can find that? Okay, if you look at the graph, this is the current graph. Okay, you cannot get that the voltage, but we have found that from 0 to 2 millisecond the voltage can be represented using this function, right? Okay, and this is from 0 to 2 milliseconds. So basically using this we can find out what is the voltage at 2. Okay, so voltage at 2 will be basically what is our function? 10 times 3 power 3 t square. So what will be the t here now? 2. Okay, t will be 2. Okay, and square. Okay, so what will be the answer here now for this case? Okay, initially the voltage will be, so 2, this is milli, right? So 2 milli. Okay, let me make it clear here because the unit of the time is milli. Okay, so 2 milli basically 2 times 10 power -3 square. Okay, so if you simplify this one, this comes out to be basically 4 millivolt. Okay, or 4 times 10 power -3. So this is this thing. Okay, let's put it here. So 4 times basically 10 power -3 plus 1 over c. What is the c here? 4 micro. So 4 times 10 power -6. Okay, this -8 will come outside, so it will become basically -8 times 10 power -6. And what we are left here inside? So integration from 2 to t, a constant. Okay, so that will be basically a constant number here. Now what we can do here, just a further bit simplification. So 10 power -6, 10 power -6 will be cancelled. So -8 divided by 4, that will give me -2. Okay, so we have here basically 4 milli. Okay, then we have basically okay, 4 milli, and this will become basically -2. So what is the integration of a constant? T. Okay, and we need to put up the upper and lower limits. Okay, so the answer will be 4 times 10 power -3. Okay, of course that terms will be coming there. Okay, then multiply with the okay minus, okay, 2, upper limit will be t and lower limit will be -2 basically. Okay, so further simplification will give us the final answers that basically will be, So we have here basically 4 milli. Okay, again this is time is in milli, right? Okay, so this is 2 milli basically, so 2 times 2, that will be give me basically 4, right? All right, let me just simplify this one. So 4 times 10 power minus 3, so minus 2t, and minus minus plus, so this is 4 milli, right? 4 times 10 power minus 3, so 4 and 4, that will become 8, basically 8 milli here, and minus 2t. Okay, so that will be basically the voltage for this case. Now further, if you just want to calculate the power, so that will be simple, because the power is basically, we got the expression, okay, for both cases, like from 0 to 2 millisecond, we know that what is the current, okay, and then from onwards we know that what is the basically, uh, so let's do that. Then 2 to 4 millisecond, so from 0 to 2 millisecond, what was the current? The current expression is basically 8 times 10 power minus 3t. Okay, so the current is 8 times 10 power minus 3t, and voltage we have found that, right? So what is the voltage from 0 to 2 millisecond? The voltage is 10 power 3 times t square. Okay, we want to calculate the power, so power is simply what? Power will be voltage multiplied with the current. Okay, so these two things are just simply multiplied, so that will basically become what? Okay, this 8 multiply with this, okay, that will be 8, so 10 power 3, 10 power 3, that will be cancelled, so t times t square, that will become t cube. Okay, this is the power from 0 to 2 millisecond. Now let's have a look at for 2 to 4 milliseconds. For this case, our current is basically minus 8 micro, a constant, and the voltage we just found that it comes out to be, what was the voltage? Voltage is 8 milli minus 2t, right? So 8 times 10 power minus 3 minus 2t. So what will be the power? Power is simply voltage multiplied with the current. Okay, so current is minus 8 times 10 power minus 6. Voltage is 8 times 10 power minus 3 minus 2t. Okay, so we can just simplify this a bit. Okay, so minus 8 times 8, that will be minus 64. 10 power minus 6 times this, okay, that will be 10 power minus 9. Then minus minus plus, okay, 8 times 2 16 minus 6 times t. Okay, so that could be the answer for this case. Okay, we can further do the plot for this one, and we can get the exact answer for that. So this was the purpose of this question here, like we can find the voltage and the power. Thank you so much.